Now without further delay, I'd like to turn conference over to your presenter, Michael Wang, Lead Program Manager, SQL Server, Relational Engine for Microsoft. Michael, you have the floor.
Okay. Okay. Good morning, everybody. As you guys know, in the next release of SQL Server 2008, we have introduced several SQL system data types, and this is a series of talks, and I'm going to talk about the new data and time types we introduced in the new release today. And next week, I have another talk basically regarding another data type we created for the hierarchical data management. So I will start with the new data and times. So if you guys have any questions during my presentation, you can feel free to just raise your questions, and I try my best to answer to give you good answers during my talk. Okay, give me 1 second because the slide is getting slow. I try to get to the next slide.
Scenarios and requirements.
Yeah. How come I don't see that? Interesting.
Looks like we're on slide 3.
Yeah, but I couldn't see that, by the way.
Oh, okay.
On my screen.
Do you have a hard copy that you want to go off of, and I can flip the slides for you?
Yeah, so that's fine. So yeah. Okay, so right now we're on slide 3. So basically, as you know, the new DATETIME type is one of the most wanted features for SQL Server. I know people really want this new DATETIME support for several years. So finally, this it's very good. I mean, it's a very good news in this new release. We're going to provide you, the new support for the new DATETIME type. So let's go through the scenarios and the requirements we have collected before we introduce this new feature. So the first one is, we know people definitely want to separate date and time types instead of the existing date time types together. So for example, for applications, let's give an example like human resource applications, about people's birthday. So people only want the date-only type rather than you have both date and time parts. It's not only it saves some storage space, also it's good for performance, because otherwise you use date and time types for the birthday, it's going to waste the time portion. For the time-only type, it's also there's very common use in the application, for database applications, particularly when you want to create database column to reflect recursive time. So this is very useful in the real application world. The second requirement and scenarios we have collected is people want to larger fractional second positions for the time portion, because as you guys know, the current DATETIME only supports the fractional second positions up to 3 milliseconds, which is kind of smaller. It's not aligned with what Windows and .NET provided. So when people try to generate the system data, they will lose the precision because we don't allow the larger precision bigger than 3.3 milliseconds. Also, another requirement is regarding the date. People want large range of data as well, because currently the DATETIME type only support start from 1753, year 1753. So for people want to enter any year before that date, we're not able to do that. So besides that, another very important scenario and the requirements from the customer and all the database application world is people want to time zone aware DATETIME type. Because as you know, when people develop a globalized regional application, if you only have date and time part without a time zone awareness, the DATETIME becoming just ambiguous. So without a time zone, a DATETIME in one region it cannot be considered comparable with DATETIME in another region. So this is another very important requirements which we have collected. Again, the other two requirements also very important. Is we know the current DATETIME type is not fully compatible and equivalent with the SQL standard. So the new type we introduced, we really look at the standard very carefully, and we target to make the new type to be SQL standard compliant or equivalent. The last requirement we also received heavily is about when people want to migrate from other database vendors, in particular for Oracle, from DB2, from MySQL. So the new types will help us to people to have a seamless migration story, because now we have the same type as the competitors have. So that's really solve people's migration pain points. So if you have any questions, again, just feel free to raise this in the question manager. So I will try my best to answer it. Okay, so now I'm in slide 4. So this slide will give you an idea about the new date and the time types we introduced. I'm going to talk about the date type first. So basically, as I said earlier, we introduced this date-only type, and the type is basically based on a Gregorian calendar. It's from year 1 until year 9999. So as you can see, the year range is increased. So now you can support any year before 1753. And the standard format for the date type is the ISO standard format. It's started with 4-digit year and the month and date. It's a SQL standard type. Again, we're fully aligned with the SQL standard for this date-only type. Also, we also did some improvements to make sure we have very efficient storage size for the date-only type. So far, it's a fixed storage size. It only takes 3 bytes. It's kind of increased. We reduced 1 byte from the existing data and time type for the data portion. On the other hand, we support almost every industry standard date string literary format, including the ISO standard format, the W3C XML format, the ODBC format. So a lot of formats we provided for support this new date type. So you can see on the second half of the slide, give a very simple code example to tell you what this type is about. How you can give a year 1, without any problem inserting into this type the database. And you can create a variable. You can just do whatever you have done before for DATETIME types, and the only thing is the date-only type. Yeah. Let me take a look and see if there's any questions so far. Yes. Okay. So the first question, people seem to have some problem to see the slide. I hope that I think I got the same problem earlier, but I don't know if this problem is still there. Then let me see. The second question is about. Yeah, of course, any data before 1753 is not accurate, as we didn't have accurate data keeping before then. Is that highlighted in the documentation? So the question is, for the date range we increased, is that highlighted in the documentation? The answer is yes. So actually, if you look at the July CTP4, if you go to book online, we have all the new DATETIME types specified very clearly over there. I'm pretty sure you can find that. If not, drop an email to me, so we should fix that. But in general, I don't think there's a problem. So the question about storage size, why 3 byte storage size? Basically, I'm not sure what the question is really asking. It's about the 3 byte storage size is too big or too small. So basically, what I'm saying is we optimize the storage size to make sure we don't waste storage size for this new type. So we did some optimization in the storage in order to save the storage. Also, it's good for memory efficiency. So if that not answer your question, so I'd like to hear more from you, so we can just keep going. So yeah, the last question I have is, will get data return a date or date time? So this is a very good question, because in the next couple of slides, I'm going to have something specifically talking about buildings. You will hear that. So in general, I can give you a specific answer about what the get data is doing. Okay, so let's go back to the slides. I try to save some time here. Okay, so I'm on slide 5, and this is about the time-only type. We created it. So as you can see, it's a time-only type. It's going to support larger fractional second positions up to 100 nanoseconds by default. We also provide a so-called optional fractional seconds parameter for this type. So instead of using the default, you can specify the parameter from no fractional precision at all, or any fractional second positions between 0 and 100 nanoseconds. Why we choose 100 nanoseconds? Because that's what currently Windows supports. So we really align with operating systems and also align with the .NET. Again, it's the default format for the time is standard format. So besides the standard format, we also support other standard format as well for the time type. This is also aligned with the SQL standard. So we make that equivalent. In particularly, if you look at the optional fractional second precision parameter, it's also part of the standard. Because we provide this parameters, so the storage size of this type is going to be a variable storage size. So based on the fractional second precision you are giving, it's going to be from 3 to 5 bytes of the storage size in terms of the range. So that will give you some flexibility, basically, depending on your really application needs. If you want to save storage size, you can use the parameter to specify it. Again, the second half is give you a very quick example in terms of how you use this type. As you can see, you can specify this. In my example, I specify the column by using a 0 fractional second precision. So that only requires 3 bytes in storage size. If you look at the last example I have, when I declare a time variable, you can give a value which has larger fractional second precision, which is larger than the existing one. Let me go back to the question manager and see if there's any questions. So the question is that support string literal format means the data values in the insert statement could be entered in any of the list formats. And the answer is yes, that's correct, because the string literal format is used in any DML SQL statement, like update, insert. Also, when you use set, you try to assign value to a variable, or you have a store procedure, you have a parameter you want passing as a string, a literal. But in general, we support the implicit conversions from string to any of the new data types to give you a very easy flexibility for you to give you value in string format. So the answer is yes. Okay. Yeah, I think people got a problem with the slides now. It's okay, so that's good. So the next question is about 0 and 6 parameter defined for nanoseconds. That's a very good question in terms of how you define the fractional precision in seconds, by using the parameter. I have another slide later to specifically talk about this. I will give you more details. I think you should be able to find the answer by that saying why it really got there. So another question is about what functions are available for time. Very good question. Again, I do have a slide talking about the building functions. So we will get this, in a couple of slides later. Let's go back to the slide As I said earlier, right, I'm on slide 6. If any people just come in or haven't followed me on the slide, I'm on slide 6 in terms of for the time zone enabled datetime type. So basically, I mentioned in the earlier in terms of the scenario and the requirement to have time zone aware the datetime type is becoming a very hard demanding, from the database application world. So in addition to the separate date and time types, we also introduced this time zone aware type. It's called date time offsite. So I just want to give you a little bit clarification in terms of the naming. So basically what this type means, a date portion plus a time portion plus a time zone offsite portion. So you have 3 parts for this type, to contain. So this type again is about basically you can enter the time zone offsite together with the date and time portion, from any region where you know the time zone offsite. And we also internally we store the time zone offsite, has been inputted or has been given from the user. And we also, the type itself, the value is being stored in the database and processed as the UTC. Why are we doing that? Because as I said in the beginning, the ambiguous is the problem. So if you have datetime types from different time zones, it's very important to have a unique value for comparison, for sort and for index. So it's stored in the database as UTC value. However, you can retrieve the time zone offset, original time zone offset, for query purpose, for display purpose, for any time zone manipulation purpose. Again, this is because this is a type that has a time portion. So it's aligned with the time type. We support up to 100 nanoseconds as a default. Also, you can specify your fractional second precision as the optional parameter. The time zone offsite range is basically standard. It's from -14 hour minutes up to plus 14 hours and minutes. And the default format, as you can see, is really the standard ISO format. You have the date portion, the time portion, and have the time zone offset portion, which have the sign to represent the real time zone offset value. Again, this is in SQL standard. There's also an equivalent type as this. Well, most of the functionalities of this type we provide is very equivalent to the SQL standard type. However, the naming is a little bit different. The SQL standard calls this type timestamp with time zone. And the reason we couldn't use the SQL standard type because in SQL Server we do have existing type called timestamp. Somehow that naming space has been taken. So unfortunately we couldn't really fully align with the standard, even though for the naming. Again, this type is very important for XML and web service purpose, because I know the time zone aware type has been used a lot in the web service world. On the other hand, this is same as the time type. It has a variable storage size because we allow the fractional second precision to be specified as optional parameter. Again, in the bottom half, you can see the quick examples. So as you can see, I go back to the original question people asked, all the string literal format, can we insert from the insert statement? Yes, so that's really the example I gave. Yeah, you can do whatever things. You can just insert any string literals in the format we supported, and then put in the database. And this one basically show you can put a time zone offset. You can see I basically currently use the Seattle time zone offset. It's daylight saving aware. The standard time zone offset is -8, and right now it's -7. So let's go back to the question and see if there's any questions pop up. The question is declare. I think it's asked the question about my examples for the time type. So is declares a variable with time 0 the same as declare a temp variable with time? No, the answer is no, they're different, because as I said earlier, if you don't specify the parameter, by default, the time type will be in the 100 nanosecond precision. So the default is always the largest one, and if you specify time 0, that means you don't have it's a 0 fractional second. Yeah, sure. Another question is, does the new daytime offsite date type support calculation and storage daylight saving information? Very good question. I will have slides in terms of limitations in the very end talk about this. In the current CATMI in the SQL Server 2008 release, we don't support daylight saving in the database server. So daylight saving is kind of a complex a topic, because not only because we have to it's government control. There's some geopolitical issues in terms of the daylight saving information. So in order to maintain the daylight saving information in the database, there's some things we need to really figure out before we make a decision. So we don't want to provide any partially solutions for daylight saving time in this release, and we would rather to provide you a full support of daylight saving time. So that's in our plan for the next release, and we will make sure, because this is one of the hot topics in our list for the next release. Another question about the existing current timestamp built-in functions asks whether that returns the daytime offset value. Very good question. Again, we do provide a new built-in functions to return the system date time offset value. I'm going to talk about specifically in the built-in function slide. So you will hear from me when I get into that slide. Another question is, does SQL Server support time zone names? Very good question. Again, this is associated with the daylight saving time support. So in SQL Server 2008, so far, the current solution, we don't allow any time zone names besides time zone offsite value. So that's a limitation for this release. However, this is in our list. As I said earlier, it's together with the daylight saving support. So we will definitely, try to provide a better solution in the next release of SQL Server. I'm going to go to the last question. Then we go back to the slides. So regarding the UTC offsite, is the offsite valid against valid offsite? So this question is about, if you give a invalid offsite, does the server validate the value? And the answer is yes, we do validate the value. If you give me a wrong offsite, I'm going to throw an error. However, the validation is really based on the range, but I don't think the validation is time zone, is regional aware. For example, if you try to give me a time zone offsite, and you mean that for Seattle time zone, but you give me something, I don't have any information to know where that's what you want for Seattle. So I'm going to only validate, the value from the data perspective, but not from the regional perspective. Okay, let's go back to the slide. Okay, so I'm on slide 7. Going to talk about the last new daytime times we support on this new release. The type is called daytime 2. I guess when people see this name, you're going to pop up some reactions, questions about why this called daytime 2, or some people feel, well, this must have something to do with the existing daytime. So the answer is yes, that's correct. So basically, we create this type specifically for enhancement of the existing daytime type. And so this new daytime 2 type, based on the existing daytime type, we support larger fractional precision, larger year range, and optional fractional precision. So basically, most of the major features, the requirements people want for daytime type, we add to this new daytime 2 type. The difference between this type and daytime offsite type is this type is not a time zone aware type. That's why we create this, because we don't want to break the existing date and time type, because we really care about the backward compatibility. We don't want to break any existing apps when people use the existing date time type. However, this new daytime 2 type, you can consider, we do suggest people, if when you deploy your new application, you want to upgrade your application, this is the type you definitely want to consider for date time type without a time zone awareness. Again, this type, because now we support larger fractional precision and larger year range, it's fully aligned with the .NET native date time type. This is really one of the highlights in terms of people can provide consistent programming model and application model between .NET and the database and SQL Server database. It's equivalent to the SQL standard type called timestamp. So we have a very close equivalent feature on this type. The only difference is the naming. Again, it's also a variable storage size, because it accepts the optional fractional second position. So it's 6 to 8 bytes in terms of variable storage size. And as I said, again, this is a recommendation for feature development of existing SQL, to replace the existing SQL datetime and small datetime. So it's, by having this type, you don't need the existing datetime and small datetime, so you can achieve everything the existing type does. So let's go back to the question manager, see if any questions. Okay, that's good. So I have one here. The question is there a small date time 2 date type? Very good question. The answer is no, because we don't need a small date time 2 date type, in particular from the fractional second position perspective, because now this new date time 2 type provides you this optional parameters. So if you specify 0, that's basically equivalent to the small date time type and give you a large year range. So we don't see any necessary, we have to create a small date time 2 type, because we really want to scope down how many types we want to create. We don't want to confuse people by creating so many types. Let's go back to the last question here. The question is, will there be a small smarter name for datetime 2 which does not remember to the Oracle types? Very good question. Because of the time limit, I'm not going to specifically talk about why we gave this name. I know this is, we have a lot of discussions. We did some surveys in terms of choosing the name. It's not perfect, so there's a lot of suggestions on what the name is supposed to be. In general, we think the reason we choose datetime 2, we feel, based on the new features that we added to this new type in terms of large fractional second position, large year range, and particularly also the optional fractional second position parameter, we think this type is more general to represent all the features. So that's why we choose that. So again, we can just I like to hear your feedback on what the best name should be given for us. So let's go back to the slide. So I'm on slide 8. So basically, this one, again, there's some questions in terms of what's the fractional seconds, why we choose 100 nanoseconds, how the optional parameter looks like, how you specify the digits. So basically, as I said, if you specify any of the new types without giving a parameter, so all the time-related types, like time, datetime offset, and datetime 2, they have a default fractional precision, which is 100 nanoseconds, and that translates to 10 millionths of a second. And the reason we choose 100 nanoseconds because we really target the Windows system and the .NET datetime type, so we provide a fully aligned fractional second precision on that perspective. Again, for the optional type parameters, basically the parameter means number of digits to represent the fractional second part of the second. So give an example, you have to see the table. So 7 basically, based on the number of the digits after decimal point, the 7 represents 100 nanoseconds. So if you specify 0, which means you don't want any fractional second positions, you don't have anyone. And so based on that, as you can see, because we support this optional fractional second position, the position and the scale metadata for the new date and time object is becoming much more meaningful than before. So you can consider, numeric, the precision and the scale is very important. So for this new date and time type, in order for you to figure out the fractional second position part, so the scale information becoming useful, and it definitely give you the number of digits to represent the fractional second precision after the decimal point. For the precision part, basically, I just want to give you a clarification what that means. So as you can see, the precision number really represents the number of characters in the standard default string format for each of the types. So the precision is also going to be variable depending on the precision you are given. So basically, you can say it depends on the scale. So, oops, sorry. So let's go to the question manager before we get to this slide 9. So the question is, does SQL Server support timestamp? I assume the question is about, does SQL Server support the SQL standard timestamp? As I said earlier, the date time to type can be considered as the equivalent to the timestamp type. And the reason we didn't use the same name as the standard is because in SQL Server 2005, we do have timestamp type use the same name. So unfortunately, we couldn't use the same name because the name has been taken. Again, so you got it, but it's in a different name. So the next question is, can you compare times with different accuracy seamlessly? For example, on table time 0 and another is time 4 will actually allow the comparison. And the answer is yes. As I said, we do allow, in addition to the implicit conversions between each type, we also allow the comparisons between all and the new and existing data and time types. So when you have a different position, the comparison will happen. However, because you have different position, we're going to use the rounding rule to really, based on the largest, the value has the larger fractional second position. So we do the comparison. So the comparison is definitely allowed. Again, the next question is also about the timestamp. So if the timestamp name is already in use, why not introduce support for encoding type names in square brackets and name new type timestamp instead of datetime to and timestamp with offset instead of datetime offset? Very good suggestion. I was, again, as I said, unfortunately we couldn't use the timestamp, and using the square brackets is a very good suggestion. We will, go back to really look at the naming if that's really the biggest concern for you guys. So another question is why are the odds that one could return 2 identical date lines with 100 nanoseconds precision? Yeah, I'm not so clear what about the question is. So I think, David, I might just get back to you, offline or maybe later during the Q&A. The next question is, have you talked to the .NET team about adding system.date and system.time types? A very good question, because when we introduced this new datetime types, we do have a very close relationship with the .NET team in terms of how we sync up the new the type system specifically to the new datetime types. Basically when we create the new datetime offsite type, in the .NET team also create the same type in the .NET framework. It's also called datetime offsite. So we have really alignment with the new types. And for the date and separate date and time type, I think .NET team is considering, but it's not going to be in the next the new release of .NET framework. But again, as I'm saying, we do have a very close relationship in terms of this new types. Okay, I will go back to the question later, so let's go back to the slide because I'm kind of running a little bit slow. So I'm on slide 9. As you can see, because all the new types we created, they're native types. So as you can see, all the functionalities on the server side, in terms of is type related, we all support all the functionalities. As you can see, not only the DDL, DML, the parameters, variables, conversions, XML, index, user-defined type, anything you can think about, any existing functionalities to support any of the existing native types. This new types we support all the functionalities. So, I mean, slide 10 is for the continuous about the server functionalities. So basically, people have a lot of questions about building functions. Building functions is very important, particularly for the date and time types. So for all the existing building functions has the date time related functionalities, we extend them to support all of the new types. For example, like the cast and the convert function, we definitely support all the string literal formats for the new datetime types. We also provide a new style for you to convert. If you want to get the UTC value or you want to get the local value for the datetime offsite type, you can use that new convert style to do that. And also, we realize we have a very strong request in terms of people when you want to use cast and convert to convert the datetime types. And people worry about if those datetime types you're going to convert, it's an indexed column. If you use cast convert, you're going to lose the index seek ability. So we basically add some support to make sure the cast and convert function, when you call them on any of the new date and time types, you're still going to keep the index seek ability rather than you suddenly from an index seek becoming a table scan. Again, I just noticed there's a typo in the explicit conversion. I have a case there, so it should be cast. Sorry for that. Again, there are 4 very important time specific functions: date add, date diff, date part, and date name. So all the 4 functions we support all the new types, and we also add 3 new date parts in terms of the new features. So there's 2 of them specifically for the larger fractional precision to microseconds and nanoseconds. For people, if you want to get a data part on microseconds, you can specify that as well as nanoseconds. Also, we support date name and date part for you in order to retrieve the time to offsite. So you can specify a time to offsite data part. So you can specifically to retrieve the time to offsite part from the datetime offsite type. As a bonus support, we support this so-called ISO week number. That's basically majorly from the Europe customers because currently We don't have the weak number support we have soon. The data part function is not fully aligned with ISO standard, and that's bringing a lot of difficulties and pain points to our customers. Even though they can use user-defined functions, but performance is really a big concern for them instead of building functions. So this is again a bonus feature. We add this in along with this new DATETIME support. Oops. That's some problem. Okay, so I'm on slide 11. I try to to get more slides going, so I'm not going to answer questions right now. So I will try to answer those questions at the end. So as you can see, instead of adding support for the existing building functions, we also add a list of new building functions. So there are 3 system functions we added for you to retrieve the system type. Basically, it's about the system DATETIME and UTC DATETIME. And both of the functions return the value by using the DATETIME2 type and return the current system database server system date and time type without the time zone offsite. We also have another function which is very useful for people to get the time zone aware system type. It's called system DATETIME offsite. As you can see, it's returning you the DATETIME offsite type, the system value from the system. And we also, based on the operating system setting, the value you get will be daylight saving aware. Again, what I'm saying is this is dependent on the operating system of in which your server is running. Based on the setting, if you set the DSP enable, you will get a daylight saving value return. We also provide other 2 functions specifically for time zone offset manipulation. So one of the functions is called toDatetime offsite. So this is specifically, you can consider this as a convert function from any of the date time types without time zone aware. If you want to convert to a DATETIME offsite type, you can specify, by using this function, you can specify time zone offsite. Then we will get that converted to the DATETIME offsite type as you want. So switch offsite is basically means you can provide when you have a DATETIME offsite column or variable, you can, if you want to populate the UTC time and knowing what is the local DATETIME in any of time zone offset you are given, you can use this switch offsite function by providing a time zone offsite. That will give you the ability to figure out a different local time in different time zones. For example, for TV program application, this is a very useful function because if you store the UTC value in the database for all the program schedule and you want to know, okay, what is the local showtime in Seattle? What is the local showtime in New York? You can use this function to achieve that functionality. So I'm in slide 12. Again, in addition to those basic functionalities, all the functionalities we added for the new DATETIME types, we also provide some advanced functionality along with this DATETIME improvement. So one of the highlights is about down-level client support. So we do support down-level clients when you connect to the SQL Server 2008 server. So because none of the down-level clients has the support for the new DATETIME types. So in order for you to be able to retrieve the value of the new DATETIME types from the server, so we basically send the string in the standard format for each type across the wire. So you can just retrieve them as a string value, which have all the correct value represented in string format. So instead of showing exceptions, we provide this optional functionality for you for down-level client support. We also provide, because now we have the DATETIME offsite type, it's a very good news for XML support. So in SQL Server 2005, because we don't have the time to offsite time, so there's no way for you to preserve the time to offsite. So when the XML, retrieve any XML value has the time to offsite, the time to offsite has to be cut, and the value has to be normalized to UTC, and the offsite part has been lost. So because we have the datetime offsite type, so the SQL XML definitely take advantage of it by changing its storage format. So right now, if you have any value in the XML file or from web service from a LISTO documentation, the time to offset portion has been preserved in the database. In addition, we also support this .NET Nullable T type. The reason of that because in SQL Server 2005 we have to create those so-called SQL types in order to really support the nullability, because .NET type doesn't have any sense about the nullability of the SQL types. However, we figure this is kind of against the programming model of .NET framework. So instead of create new SQL types, we just add the support for support the nullable T type in .NET. It's not only for the new date and time types, it's basically supported for all the native types in .NET. So right now, you can just use the nullable T if you want to write any SQL CLR application in SQL Server 2008. So in the next several slides, I'm going to give you some typical use cases based on the new features. So you can have some common idea and sense in terms of, okay, what probably will be the highlight, what the new features is useful for you guys. The first use case is in this new release for the new types, we add a standard support to make sure the ISO standard date format, which is in 4 digits, year, and with month and date, is independent to the date format or the language setting. So what that means, as you can see from the example, if you have the date format set to YDN, however, if you give a value in this standard format, it's not going to be affected by the settings. So this is basically aligned with the standard. This is the standard format. It shouldn't be really affected by the language setting or the date format setting. The second example, as you can see here, is about those system building functions, right? So as you can see, when you call those functions, you will get the system values from the current machine where you're running your database. You can pay attention to the system data and offsite type. It's basically give you, I'm running this on my machine, so I got a time zone, a daylight saving aware time to offset is -7 from the Seattle, because right now I'm on daylight saving time. Also, my machine is enabled for daylight saving. So the next example is how do I get my current system time to offset? It's very simple. You use the date time. You use the date name function by giving a time zone data part, and then you call the system datetime offset. You will get that time zone offset return. And also, if you want to get the local or UTC date time of a datetime offset column, so you just use the convert function by specify the stale 0 or stale 1, so you will get different value to give you either the local datetime the local datetime value in the time zone offset, or the UTC datetime value. So by default, if you don't specify any of the stale, by default we will return you the local datetime value when you use cast and convert. Okay. So now I'm on. I'm on slide 13. Oops. 15, right? Yeah. So now I'm on slide 15. It's still on the typical T-SQL use cases. As you can see, in order, if you want to get a local date time, with different time zones. This is really specific about how should you use the switch offset functions. If you have a UTC value, which is a datetime offset column, a datetime offset variable, and you want to know, okay, what is the local datetime in different time zones? You just use the switch offset function. That will return you, the datetime offset different time zones that you can use convert to retrieve the datetime part or the date and the time part. This is give you flexibility in terms of for you to manipulate between the local datetime and the UTC datetime on different time zone offsite. You can also use the date type. Again, I also see a typo here. It should be a date type. So you can create a birthday atomic user-defined type on top of the date type. So this is very common. Again, birthday is a very good example for you how to use the date types. Let's give you just a quick example how you use that. I'm on slide 16. Again, this is about the cat and the convert function. When you use that to convert to a date or to a time type, so basically my example is you have a datetime 2 columns, so you create an index on the column, but now for some reason you want to find, okay, where my datetime value in a specific date. So you use this convert function, you convert that to date. However, you do worry about, because it's the index column, you worry about if you call convert, you lost the index 6 ability. As I said earlier, if you call this convert and function on date and time types, you will still got index 6 plan rather than a table scan. So this is very useful, for the datetime operations, and we really try to reduce the performance impact for you guys if you want to call cat and convert, on a new datetime types. So in addition to the server support, all the server functionalities, actually we in the new release we have a policy about any of the new features we should support that across all the SQL Server product line. So in addition to the server support, we also add the full support for all the client providers, which is including the native providers for ODBC and ODB, and the managed providers, which is for SQL Client and ADO.NET. Also, in addition to that, all the SQL Server products, as I said, like the analysis service, the reporting service, the replication, the management ability tools like SSMS, SMO, and integration service for DTS. Every product, all those new types has been supported. So as you can see on this slide 17, I basically give you an idea about for those client providers, what's the date type mapping between the providers and the server type. I just want to give you some to let you know, for the ADO.NET, you can see there is the datetime offset .NET framework native type has been introduced in the new .NET version. So that's fully aligned with the datetime offset type. Unfortunately, there's no separate date and time type in .NET framework, even though that's probably going to be supporting the next .NET version. However, right now, you can use the existing date time type and the timestamp type in .NET to map your server date and time type. So for the datetime 2 type, we fully align with the .NET, the existing datetime type in .NET. So you got a pretty much very good story here for all the client providers with the new SQL Server type we introduced. Yeah, so again, as I mentioned earlier, as you can see, all the SQL Server product components, we add the support for the new datetime types. Okay, so I'm on slide 19. It's basically, here gives you some ideas in terms of some limitations or some features were not supported in this SQL Server 2008 release, but we will consider in the next release. And on top of the list, as you can see, daylight saving time. Daylight saving time support for the daytime offset is definitely one of the top in our list. That's along with the time zone name support is also going to be part of this item. The other one is people will ask, what about even larger fractional second precision, bigger than 100 nanoseconds? Because we know, for example, like Oracle, they support the fractional second precision up to 1 nanosecond. Again, definitely that's in our consideration. Also, I want to let you know the current design of support the fractional second precision as a parameter, as an optional parameter. It gives us a big space for us to extend the existing, the new daytime types if we want to go larger fractional second precision. So that's basically, I think, a very good design for the future if we want to go larger fractional precision without breaking any of the existing applications. So time zone support for time, yeah. So if you want a time zone aware type specifically for the time only type, currently we don't support that in the SQL Server 2008 release. However, we do recommend if you want, if you do have that need, you can use the daytime offset type as a workaround. The other very important thing is about the interval type. Interval is a very nice feature, basically SQL standard, and we are also considering to support the interval type in the next releases. So Julian calendar type, also to support 24-hour implementation, and to make sure whether we want to support over 59 leap seconds is also in the list, but we're not supporting in this new SQL Server 2008 release, but they all in the consideration for us for the future release. Again, this I'm on slide 20. This is just give you a quick clarification in terms of for the July CTP4 we shipped. It's including all the support for the new daytime and types. Also, in the book online, you can see all the new topics related to the new daytime and types. So feel free just go there to find what information you need, or if you feel we're missing something, please just either send us like a feedback through the connection site, or just send me by email. That's fine too. So okay, so I have I think I'm going to probably am out of time. I don't know if I can do some so I'm going to spend maybe 5-10 minutes to try to go answer some questions and see if I can give you some satisfying answers. So I will go from the bottom of the question and bottom up. So the first question is, do we support for other non-Gregorian calendars? The answer is no. So currently, we only support one Gregorian calendar, which is kind of aligned with the SQL standard. It's linear. We basically based on the linear calendar value, rather than we don't introduce any calendar support for this new daytime type. So the calendar support again is it's a very sensitive feature because it's country related, it's culture related, it's some complicated, but it's in our list of consideration. So we will see what we can do better in the future, particularly when we have this new daytime types in place. Now we have a very solid infrastructure for us to add any new advanced features in the future. So the next question is, will it be possible to use the .NET daytime type with the SQL Server time date type, or is limited to timestamp only? I think this is basically talking about the type mapping between the .NET framework type and the SQL Server type regarding the time type. So the answer will be yes. You can use the daytime type instead of the timestamp type. So the type mapping specifically in my chart I gave you is is about if you call the get value method in .NET from the data reader, by default, you will get a timestamp object, but not a datetime object. However, you can use the convert function between the timestamp and the datetime type in .NET. Also, you can call get datetime method that you will get. You can use the strong type method to call get datetime. So you will get the datetime value instead of the timestamp. So the next question is, can we use constraints when creating a new type? Of course. So the answer is, as I said, any of the new types, any of the features you consider to support any of the existing native SQL Server building system types, for example, like integer, like numeric, like the existing datetime type, all the functionality is supported for the new datetime type. So you can create a constraint on any, you can create an index, you can create a check constraint, you can do anything you can do for the existing native types for the new datetime types. There's no any limitation on that. So the next question is there a function that returns time to offset of host? If you remember, one of the examples I gave is basically you can do this by using the date name or date part function, and then you call the datetime offset. You use the two functions together, you can retrieve your current machine's time zone offset. So another question, I'm going to just answer 2 or 3 questions, then we call off because I'm kind of really out of time. So the question is, any plans for save state and save time function, or must we use the convert case? So the current plan is we'll not introduce the save state and save time function because we suggest you to use the save datetime, save UTC datetime, all the system save datetime offset functions, and then use convert to get them. So in terms of performance, also as I said, the cast and the convert does support the index seek ability. We keep that functionality without losing the index seek ability. So we suggest you use that if you want to really retrieve the date portion and the time portion of your system. Depend on the requirement, on the requirement from the customer and from you guys. We might consider to add the save date and save time functions probably in the next release. But in general, you do have a very efficient way to retrieve those right now. Let's go to another question. So what is the value of cast 0 as date time 2? This is a very interesting question. I assume this is going to be you try to cast a 0 integer value to a date time 2. I think this will give you a invalid value exception when you try to convert it as date time 2. So that's my interpretation on this. So I'm going to pick one last question, then we will call the presentation off. The question is, the interval date type should really be supported as soon as possible. I agree. So as I said, based on the time and resource constraints, unfortunately we couldn't add this interval date type in the SQL Server 2008 release. But this is really on the top of our list. We will consider that definitely for the next release. Okay, so I think I'm pretty much done for today. Again, let's go back to the question slide. So you got my email here, and just feel free to send me emails if you have any more specific questions, or you want any detailed answers, or you want some technical discussions. You're really welcome to give all your feedbacks. And again, we're looking for feedbacks. because we still have some time to do something more for you guys, and we really like that. Okay, thank you guys.
And also as a reminder, we have another live meeting next week, same time, just a week later. We appreciate everyone attending.
Great. And as one final reminder, audience members, if you'd like to print off a copy of the slides, again, to do so, just go up to File in the upper left-hand corner of your console, and then from the drop-down, select the Print to PDF option. And you're welcome to stay logged into the conference to do so. But at this time, this does conclude today's live meeting. Thank you for joining us, and you may now all disconnect.